I'm with you here again. This is Ms. DeLoss. We're looking at Unit 1, Skill 8. This time we're talking about parallel lines. And we're going to actually refer back to a previous skill, the angle bisector construction, to create those parallel lines. So in order to do this, we will use the angle bisector construction. It's important to remember to keep the same radius. So our first example has us constructing a line parallel to the given segment, which is AB, and passing through point C. So eventually I want a line that's parallel, never going to touch AB, going through C. So what we're going to do is start by connecting A to C. And you can connect beyond it, or you can connect just to it. Totally up to you. Now we've got this angle here, and this should look familiar to you based on the angle bisector construction, where we put our center on A, we open it up to some radius. This radius, though, has to be opened up to C. So again, open it up all the way from A to C. You're going to swing that big smiley arc. That gives you another point. We'll choose to call this one D. You don't have to have it labeled, but it's easier for us to talk about it in that way. Keeping the same exact radius, I'm going to put it on C and swing a little baby arc. I'm going to then keep the same radius again, put it on D, and swing another baby arc. Those two have crossed. I'm going to choose to call this point E. Again, you don't have to have a label for the letter here. They didn't ask us to, but it does help when you're talking about it. Now, to make a line parallel, I'm just going to connect through C to E. To make the angle bisector, I would go from A to E, cutting that big angle in half. But I'm not making an angle bisector, I'm making lines that are parallel. So here, through E. This line that I just drew is parallel to E, or parallel to AB. If you want to put arrows on it, you could have also extended it past C and put arrows on this side. Totally up to you. As long as you have a line that's parallel to this one, you're good. Same thing's going to happen down here. I have to construct parallel to this line passing through point P. So I'm going to choose to make a point somewhere on this line. You get to choose wherever you would like to make the point. You could put it here if you want, but keep in mind you have to connect that then to P, and then you're making your angle go this way. I'm going to choose to make my angle go this way where I have the space. Again, totally and completely up to you. I'm going to choose to call it A. I'm going to also then connect A to point P. I'm going to put my center on A, just like I'm doing an angle bisector construction. Close it up at P for my radius. Swing that big smiley arc. I now have, let's call it point B. From here I'm going to keep the same exact radius, put it on P, put it on B, swing two baby arcs from each individual point. And remember again, for the angle bisector you'd come from A, but we're not making an angle bisector, we're making parallel lines. So now I connect from P. I didn't even label that point, and that's okay, right? I don't have to have a label on that unless they tell me to, and they did not. So now that line that I just drew is parallel to my original line that they gave me. If you look on the back side of this paper, we're going to talk about some angles that are formed by parallel lines, and we're going to focus more on these in Unit 2, but we're just giving you a little bit of a preview right here. If we have these parallel lines M and N and this transversal T, we can find 4 different types of angles. Alternate interior angles are formed out of a Z with those parallel lines. So if I highlight a Z using line M and the transversal and line N, I notice that angle 3 and 6 are inside the parallel lines, therefore interior, and they're on alternate sides of the transversal, on opposite sides in other words, and therefore they are called alternate interior angles. They are congruent to one another, so keep that in mind. Let's just take a second to define interior versus exterior. So if we have lines that are parallel, and we have a transversal, that transversal is called T. Interior means that you are on the inside of those lines. If it were exterior, and we had the same exact picture, again with a transversal called T, exterior would be anywhere on the outside of those parallel lines. Let's talk about what alternate versus same side means. Same picture, same transversal. Alternate means on opposite sides. Okay, so alternate is opposite sides of transversal. Whereas same side, can you imagine? Same side of your transversal means that you are literally on the same side, whether they're interior or exterior, you are on the same side of the transversal. Here's the transversal, these are both on the left side. Here's the transversal, you could have some on the right side, they could even be interior. Okay, so you're going to hear all those words sort of connected together now. We have to name another pair of alternate interior angles besides 3 and 6 though. If I were to look at a backward Z, I could also find alternate interior angles. Boom, boom, boom. 4 and 5. And truthfully, I should have written congruent. If I look down, we have alternate exterior angles. So exterior being on the outside of our parallel lines. So they've got angle 2 and angle 7 labeled together. So angle 2 is congruent to angle 7. But I also know that I could have the other alternate exterior angles, 1 and 8. You'll notice that we use arc marks to show angles are congruent. Instead of hash marks, we use arc marks. 2 arc marks means another pair of angles are congruent. If I look at same side interior or exterior, they are not congruent, they equal 180 degrees. Okay, so angle 4 plus angle 6 equals 180 because they are on the same side within the parallel lines. Another option would be something like angle 2 and angle 8. Angle 2 plus angle 8 should sum to 180. This is related to corresponding angles, and I'll explain why they're related to one another in a second. Corresponding just means matching. So they show us that angle 2 corresponds with angle 6. These two angles are congruent. If you can imagine, I take these 4 bottom angles, 5, 6, 7, 8, I pick them up and I plop them down on top of 1, 2, 3, 4. 2 and 6 are in the exact same spot. Therefore, they're congruent to each other. So that's one pair of corresponding angles. Another pair could be like angle 1 and angle 5. They're both in that upper left-hand corner if I focus on each as an individual set. Angle 1 congruent to angle 5. Let's see. What about angle 4? I'm going to put 3 arcs on this one. Angle 4 matches with angle 8. Therefore, it's corresponding and therefore congruent. And last but not least, we have angle 3. 4 arc marks, holy moly. Corresponding and congruent to angle 7. Now if I take it back down here to same side exterior, the reason they're not congruent and instead add to 180 is because if I look at angle 4 and angle 8, those two are corresponding. These two are congruent to one another. So if I say that this is 120 degrees, this one is also 120 degrees. But it's got an angle next to it on a straight line. This must be 60 degrees to make 180 for that straight line. Angle 2 matches with angle 6, therefore this is also 60. So when I take some same side interior or exterior angles, same side interior 4 and 6 must add to 180. All right, I know that that was a lot of information, but take a second to review it, make sure you understand it, the difference between interior and exterior, alternate and same side. And then the two key ones you definitely have to know are alternate interior and corresponding. These come up a lot. Okay, so make sure that you study them, review them, understand them, maybe make some notes down in your summary section about them, and then come practice next class.